The year was 1981. Gas prices were still haunting America. The muscle car era was dead. Emissions regulations were tightening. Fuel economy had become the new battlefield, and every automaker in Detroit was desperately searching for a miracle. Then Cadillac announced something that sounded impossible. An engine that could think. An engine that could decide in real time whether it needed 8 cylinders, 6 cylinders, or just 4. It wasn't science fiction. It wasn't a concept car. It was going into production, and Cadillac believed it would change the automotive industry forever. But what almost nobody knows is that this revolutionary engine would become one of Detroit's quietest engineering disasters, a failure so embarrassing that General Motors spent years trying to forget it ever happened. Most people know Cadillac as the king of American luxury. They remember chrome. They remember giant V8s. They remember effortless power. They remember seats that felt like living room sofas and hoods that stretched toward the horizon. What they don't remember is the moment Cadillac accidentally turned one of the most advanced automotive ideas of its era into a public nightmare. And the craziest part? The idea itself wasn't wrong. In fact, modern luxury cars use the same concept today. The real disaster came from a hidden weakness nobody fully appreciated until it was too late. And what happened next nearly damaged Cadillac's reputation beyond repair. To understand how this happened, you have to go back to the late 1970s. The oil crises of 1973 and 1979 had shaken Detroit to its core. For decades, American automakers had lived by one simple rule. If customers wanted more power, build a bigger V8. If they wanted more comfort, build a bigger car. If they wanted more prestige, add more cylinders. Size equaled success. Displacement equaled prestige. Horsepower numbers were bragging rights. Nobody asked about fuel economy because nobody cared, but suddenly fuel economy mattered. Federal fuel economy regulations were tightening every year. Japanese imports were gaining market share. Consumers who once dreamed about massive V8-powered cruisers were now asking uncomfortable questions about fuel consumption. Lines at gas stations stretched for blocks. Prices doubled, then doubled again. The American automotive dream suddenly felt expensive. Cadillac faced a serious problem. Its customers still expected smooth V8 power. They still wanted quiet cabins and effortless acceleration. They still demanded the prestige that only a Cadillac could deliver. But regulators wanted efficiency. The government was implementing corporate average fuel economy standards. Automakers had to meet specific fuel economy targets across their entire fleet. Miss those targets and face massive financial penalties. How do you make a large luxury car economical without making it feel cheap? That question landed on the desks of General Motors engineers, and one group believed they had found the answer. The concept sounded brilliant. Most engines don't actually need all their cylinders most of the time. When you're cruising down a highway at 60 miles per hour, your engine is barely working. It's loafing along, using only a fraction of its potential. So why waste fuel firing all 8 cylinders? Why not temporarily shut some of them down? Use 8 cylinders when accelerating. Use 6 during moderate driving. Use 4 while cruising. Instant fuel savings, maximum efficiency, no sacrifice in luxury, at least in theory. The engineers ran calculations. They built prototypes. They tested the concept in laboratories and on test tracks. On paper, everything looked perfect. Fuel economy could improve by as much as 25% under certain conditions. That was enough to transform Cadillac's entire lineup. The project became known as the V8-6-4, and in 1981, Cadillac proudly introduced it to the public. Under the hood sat the 368 cubic inch Cadillac V8 that translated to approximately 6.0 liters. The engine used a 4.06-inch bore and a 3.53-inch stroke. Compression ratio was around 8.0. Output was rated at 140 horsepower and approximately 265 pound-feet of torque. Today those numbers sound modest, painfully modest actually, but remember the era. The emissions regulations of the late 1970s had devastated horsepower figures across Detroit. Many legendary engines had lost nearly half their original output. Catalytic converters strangled exhaust flow. Restrictive intake systems choked airflow. Lower compression ratios killed efficiency. The performance landscape was bleak. Engines that once produced 300 horsepower now struggled to reach 150. The real attraction wasn't power. The real attraction was technology. For the first time in automotive history, a mass-produced production car could automatically deactivate cylinders while driving. Special electronic solenoids controlled rocker arms inside the valvetrain. When the computer decided fewer cylinders were needed, valves on selected cylinders simply stopped opening. Fuel delivery was cut. Those cylinders effectively went to sleep. No combustion, no fuel consumption, just dead weight rotating harmlessly inside the engine. Then, the moment more power was needed, they instantly came back to life. Valves started opening again, fuel resumed flowing, power returned. The driver supposedly wouldn't notice anything except improved fuel economy. Cadillac advertised it as the future. Journalists called it revolutionary. Automotive magazines published glowing previews. Executives believed they were witnessing the birth of a new era. General Motors invested heavily in advertising campaigns showcasing the technology. Television commercials highlighted the sophisticated electronics. Print advertisements explained the fuel savings. Dealerships prepared for what they expected to be overwhelming customer interest. But there was a problem. Actually, there were hundreds of problems, because this revolutionary engine depended on something that barely existed in 1981, automotive computing. Today, even economy cars contain dozens of powerful processors performing millions of calculations every second. Modern engine control units manage fuel injection timing, ignition timing, variable valve timing, turbocharger boost, transmission behavior, emissions controls, and dozens of other variables simultaneously. They do it flawlessly, thousands of times per second, without the driver ever noticing. But the V8-6-4's engine control module had less processing power than a modern calculator, less power than a cheap digital watch, less capability than the phone in your pocket uses just to display the time. Yet Cadillac expected it to monitor throttle position, engine load, vehicle speed, transmission behavior, vacuum levels, and cylinder activation simultaneously. The computer simply couldn't keep up. It struggled to process information fast enough. It made poor decisions about when to activate or deactivate cylinders. It couldn't adapt to changing driving conditions quickly enough. And then the nightmare began. Owners started reporting strange behavior. The engine would hesitate during acceleration. It would stumble at highway speeds. Sometimes the transition between 8 cylinders and 4 cylinders felt rough, uncomfortably rough, like the engine was momentarily confused about what it should be doing. Other times it happened at completely inappropriate moments, accelerating onto a highway on-ramp with just 4 cylinders active, cruising down a gentle hill when suddenly all 8 cylinders fired back to life for no apparent reason. The engine felt indecisive, uncertain, almost nervous. Drivers complained that their expensive luxury cars felt confused, and nothing kills luxury faster than unpredictability. Dealerships were flooded with complaints. Service departments were overwhelmed. Technicians struggled to diagnose problems because nothing like this had existed before. Many mechanics had spent their entire careers tuning carburetors and replacing spark plugs. They understood mechanical systems. They knew how to adjust valves and set ignition timing with a timing light and a wrench. Now they were being asked to troubleshoot electronic control systems that few people truly understood. Diagnostic equipment barely existed. There were no scan tools, no computer interfaces, no software updates. One Cadillac technician later recalled that the technology was years ahead of the people trying to service it. Engineers would send technical bulletins, but many dealership mechanics couldn't interpret them. The language was foreign, the concepts were abstract. The troubleshooting procedures were unlike anything they had encountered, and customers were losing patience fast. Imagine spending over $20,000 on a Cadillac in 1981. That's roughly equivalent to more than $65,000 today. You expected perfection. You expected the pinnacle of American automotive luxury. You expected your neighbors to admire your driveway. Instead, your luxury sedan was hesitating at stoplights and behaving unpredictably on the highway. Luxury buyers don't tolerate that kind of behavior. They don't want explanations about cutting-edge technology. They don't care about fuel economy if the car doesn't feel right. They want smooth, predictable, effortless power. And Cadillac quickly learned a painful lesson. Innovation means nothing if customers lose confidence, but things were about to get worse, far worse. As complaints increased, dealerships began searching for solutions. Many found a surprisingly simple answer: disable the system. Technicians discovered they could effectively force the engine to operate as a conventional V8. A few disconnected wires, a couple of bypass sensors, maybe a modified computer input. Suddenly, the engine ran on all 8 cylinders all the time. The hesitation disappeared. The rough transitions vanished. The car felt like a proper Cadillac again. Fuel economy suffered, but drivability improved dramatically. Customers left happy. Problem solved. Soon, dealerships across America were quietly turning off the very feature that made the car special. Think about that for a moment. General Motors had invested enormous resources developing this revolutionary technology. Millions of dollars in research and development, countless engineering hours, extensive testing programs, advertising campaigns celebrated it. Engineers staked their reputations on it. Executives promoted it as the future. And dealers were removing it one customer at a time. The feature wasn't just failing, it was being actively erased, deactivated, removed from existence as if it had never been installed. The irony was almost painful. An engine designed to deactivate cylinders was itself being deactivated. What they discovered next changed everything. The engineers began analyzing warranty reports and customer feedback. They studied the patterns, they reviewed technical data, they interviewed technicians and customers. A fascinating pattern emerged. The mechanical hardware wasn't the main issue. The rocker arm mechanisms worked. The cylinder deactivation hardware functioned. The valvette train design was sound. The solenoids operated correctly. The fundamental concept worked exactly as intended. When the computer told a cylinder to deactivate, it deactivated. When the computer commanded it to reactivate, it reactivated. The mechanical execution was flawless. The weak link was electronics. Specifically, the limitations of early 1980s computing power. The software couldn't react quickly enough. The processor couldn't make decisions fast enough. The control strategies weren't sophisticated enough. The sensors weren't accurate enough. The entire system was trying to do something that the technology of the era simply couldn't support. Cadillac had essentially built a 21st century idea using 1970s computer technology, and the gap between those two worlds was enormous. It was like trying to run modern software on a computer from decades earlier. The concept was sound, the execution was impossible. The V8-6-4 wasn't failing because engineers misunderstood engines. It was failing because computing technology hadn't caught up yet. But customers didn't care about technical explanations. They didn't want to hear about processing limitations. They didn't want promises that the technology would work better in the future. They only cared that their expensive cars weren't performing properly, right now, today, in their driveway. Sales suffered. Public confidence dropped. Word spread quickly that the new Cadillacs had problems. Consumer Reports criticized the technology. Automotive journalists who had initially praised the concept began publishing negative reviews. And inside General Motors, executives became increasingly nervous. The company had expected a technological triumph, a game-changing innovation that would position Cadillac as the technology leader. Instead, it had created a public relations headache. By 1982, Cadillac quietly began backing away from the system. The V8-6-4 remained available only briefly before disappearing. Production numbers were relatively limited. Most estimates suggest fewer than 100,000 vehicles were built with the system. The experiment was effectively over. Detroit moved on, or at least it tried to. For years, the V8-6-4 became something nobody wanted to discuss. It wasn't mentioned in corporate history books. It didn't appear in anniversary celebrations. Engineers who had worked on the project rarely talked about it. It wasn't a spectacular disaster like the Ford Edsel. It wasn't a high-profile scandal. It was something worse, An embarrassing reminder that being ahead of your time can sometimes look exactly like failure. And yet the story wasn't over, not even close. Because while Cadillac's experiment appeared dead, engineers across the automotive industry had been paying attention. They understood something important. The idea itself was brilliant. The timing was simply wrong. They filed away the lessons learned. They noted what worked and what didn't. They recognized that computing power was improving rapidly. And they waited. As computing technology improved during the 1980s and 1990s, engineers revisited the concept. Processors became faster, exponentially faster. Sensors became more accurate. Software became vastly more sophisticated. Electronic control systems evolved from primitive experiments into reliable, powerful tools. Suddenly, the impossible no longer seemed impossible. In 2005, General Motors introduced active fuel management. The system automatically deactivated cylinders during light load operation. Sound familiar? It should. The concept was remarkably similar to what Cadillac attempted in 1981. Only now, the computers were powerful enough to make it work. The transitions were smooth. Drivers barely noticed when cylinders deactivated or reactivated. Fuel economy improved without sacrificing drivability. Everything the V8-6-4 promised finally became reality. Today, cylinder deactivation appears in vehicles from General Motors, Chrysler, Honda, Mercedes-Benz, Volkswagen, and many others. Millions of modern vehicles use the same fundamental idea. Drivers barely notice when it activates. The transitions are smooth. The technology works. The future Cadillac imagined finally arrived. It just arrived 20 years late. And that's what makes this story so fascinating. Most engineering disasters fail because the idea is flawed. The thinking is wrong. The concept doesn't work. The V8-6-4 failed because the idea was too advanced. The engineers were right. The technology around them simply wasn't ready. Think about how rare that is. An automotive disaster that eventually proved itself correct. A failure that became an industry standard. A forgotten embarrassment that quietly shaped the future of engine design. Today, surviving V8-6-4 Cadillacs have become fascinating collector pieces. Not because they were successful, because they're particularly valuable, because they represent one of the boldest technological gambles Detroit ever attempted. They are rolling reminders that innovation is messy, that progress isn't always linear, that sometimes the pioneers are the ones with arrows in their backs. Sometimes being first is more dangerous than being wrong. Sometimes history punishes pioneers, and sometimes the future arrives before the world is ready for it. The Cadillac V8-6-4 didn't save fuel economy in 1981. It didn't revolutionize the automotive industry overnight, and it certainly didn't deliver the flawless driving experience Cadillac promised. But it did something almost as important. It showed engineers what the future could look like. It proved the concept could work mechanically. It identified exactly what needed to improve. It created a roadmap for success, even if nobody could follow that roadmap yet. Even if nobody could reach that future yet. That's why this remains one of Detroit's quietest engineering disasters. Not because it exploded, not because it bankrupted a company, not because it was fundamentally broken, but because it failed for the strangest reason imaginable. It was right too soon. And in the automotive world, being right too soon can be just as devastating as being completely wrong, sometimes more devastating. Because being wrong means you can learn and move forward. Being right too soon means you watch others succeed with your idea years later. The V8-6-4 owners who kept their cars understood something important. They owned a piece of automotive history, not a successful piece, not a celebrated piece, but a genuinely significant piece. A reminder that failure and vision sometimes look identical, that the difference between disaster and triumph can be nothing more than timing. If you enjoyed this story, let me know in the comments which forgotten engine, engineering failure, or automotive experiment you'd like to see next. And make sure to subscribe so you don't miss the next deep dive into the machines, rivalries, and innovations that shaped automotive history.